This is the demonstration video for the project Smart Power Distribution Controller for the Hybrid Solar Grid System. And the design solution includes two main components. And this is the simulation of the power source, which include the solar panel, battery, and power grid, which represent the hybrid solar grid system simulation. And this is done inside the Simulink. And another one is the main controller part. It is built inside the VS Code. So the main controller will consider the weather condition and the power source status and make the decision, give the command to the simulation here to control which power source will contribute to the load. And these two components are using the MQTT to communicate. And now I will show the current progress of our two components.
Hi, I'm Alex and today I'll demo our Python weather publisher. This script fetches live weather for Kuching and publishes two MQTT messages, one for current conditions and one for tomorrow's solar PV focus forecast. These are the libraries, constants, and API parameters for the weather. First, we initialize our MQTT client in initialize MQTT client function. It connects to broker emqx.io on port 1883 using my demo credentials and start a background loop so we can publish asynchronously. In the fetch weather function, we call the Open Meteor API with retry logic. We request hourly, daily, and current variables, everything from temperature and humidity to global tilted irradiance for our rooftop PV system. Next, format current snapshot function builds a neat text box showing the snapshot, time, temperature, cloud cover, wind speed, and rainfall. The publish current weather function calls the API, formats the current snapshot, and publishes it to the MQTT. The publish tomorrow forecast function does the same but for tomorrow's solar forecast and publishes it to MQTT as well. Finally, the run weather publisher function runs both publisher immediately, then schedule updates, current weather every 15 minutes, and the forecast every day at 6 p.m. Now I'll run the program to view the weather data. As you can see, the script publishes to the current weather and also the forecast for tomorrow. That's all for my demonstration for the weather publisher. Thank you.
Is power source simulation, and so here is the MQTT component that input is about publishing the message and output is to receiving the subscribe message, and this part is to handling the input and output MQTT message, and also including the battery BMS system inside a step machine. And here is this part is the simulation of the battery power source status. For example, right now is the battery is feeding the power to the load. So then this will turn green, which represent that now is the battery contribute the power to the load. And also, for example, now if the main controller publishing the command about need to turn on the grid, so here will output that the message is grid turn on, and here will matching and input of the grid on off for the step machine will equal to 1, and the step machine will analyze and give the proper output, which is the grid here will turn on, turn to green, which represent that now the grid is feeding the power to the load. And beside that, the model also will keep updating the battery status, battery percentage to the specific MQTT topic, which you may let the main controller know that about its status, its percentage. And for the current progress is the MQTT component is done already. And this part is still in progress, but it's almost done already.